Welcome to the second of 6 webinars focusing on effective mathematics teaching. Webinar 2 will focus on number. Now, my name is Tracy Hughes-Butters and I'll be facilitating this webinar, which has been designed to consider student errors in the PAT Maths assessment, focusing on number and what we as teachers can do to support our students to ensure that they are able to demonstrate their mathematical skills and knowledge in unfamiliar situations. From the PAT Maths data, there are 5 areas of concern that have been highlighted for our students in Catholic schools across Australia. Please note they are not in any order. This webinar will focus on the first dot point, number and place value. Now, there will be 4 questions that we will unpack. Each question will target a different year or stage level. This is the learning intention and success criteria for the webinar. Please pause and read. Now, we need to consider the enormity of the topics number and place value, and note that we cannot effectively cover everything in a half-hour webinar. So, we will draw from the PAT Maths data and analyse a series of sample questions that are similar to the questions that had the lowest achievement rates. Now, the sample questions vary from Year 1 to Year 6. I would suggest that you complete at least 2 of the sample questions. Don't just consider the sample question that targets the year level you are currently teaching, but complete at least 2. This is a big picture approach. I will lead your team through a set of focus questions that will identify the prerequisite knowledge, the key concepts and skills necessary to access the question. We will also analyse the common errors and misconceptions that could impact student choice by applying Newman's error analysis to identify the possible cause. Now, if you've not used Newman's error analysis, I will give a brief explanation. And finally, teachers will reflect on their current teaching and learning, what is supporting student learning, and what could be changed or added to improve our students' learning experiences in mathematics. And of course, there will be plenty of time for discussion and reflection. Now, I've designed a set of 4 focus questions to prompt discussion and reflection. So focus question 1 will ensure that we as the teachers understand the key concepts and the skills that the question is actually assessing. Focus question 2 will consider the prerequisite knowledge and skills that our students must have to attempt the question. Focus question 3, consider why our students may have decided on an incorrect answer due to common errors or misconceptions. And focus question 4, what could we ensure our students experience in their learning so that they are able to experience success in this type of question? Now, I will present 4 multiple choice questions in the webinar. Simply fast forward to the year or stage level that you would like to analyse. Now, I would recommend that you complete at least 2 questions in the time and not just target questions that your students would be attempting. We need to know the big picture, not just one part. Here is a sample question targeting years 1 and 2 in the area of subtraction. Now, carefully read the sample question and then consider and discuss each focus question. You may find that you want to discuss the focus questions in a different order, and that is no problem. Pause the video for approximately 5 minutes to discuss the focus questions. Ensure that someone is scribing. I would recommend a whiteboard with different coloured pens. Discuss and add to the board as you work through each focus question. When you are finished, recommence the video. Welcome back. Well, let me present my thoughts on each of the focus questions. Starting with focus question 1. Well, the key concepts and skills necessary to successfully answer this question would include reading and interpreting a multi-layered word problem. This is not some simple one-step question, and some students may struggle with the complexity if they haven't been exposed to similar styled questions. The next thing would be identifying the appropriate operation to complete the problem. Of course, there is understanding the concept of equivalence, the same. Understanding the link to subtraction and addition. And finally, being able to keep track of the changes of the 2 quantities at the same time to create 2 equal quantities. This is simple to represent with concrete materials, but how would your students complete this diagrammatically? So my question is to you, what learning and teaching strategies are you currently employing in your classroom, and what could you add to the learning to ensure that your students are competent and confident to apply these skills and concepts in unfamiliar situations? Pause the video and discuss. Question 2. What are the prerequisite skills and the knowledge? Well, the main prereq for this question is simply one-to-one correspondence. Now, let's consider each distractor in the multiple choice. Now, I will apply the Newman error analysis to code the errors. Now, if you have not heard of Newman's error analysis, then here is a quick summary. The analysis breaks down the 5 steps involved in solving a mathematical word problem. The first is reading and decoding. The student reads the problem and decodes the words and the symbols. Comprehending. The student makes sense of what they have read. Then there is transforming. The student mathematizes the problem, that is, works out what mathematics needs to be done. Then there is processing, demonstrating what to do to actually get that answer, and then finally encoding, being able to record their final result appropriately. So let's work through each distractor in this question. 10. Well, this is a reading decoding error. Students may not understand what the question is asking, so they simply add all the pencils together. 6. Well, this is a comprehending error. They have simply compared and then calculated how many more pencils Matteo has. 5 is another comprehending error. Students may have only calculated the first part of the answer, which is the total that each person will have. 3, of course, is the correct answer. 2 is a comprehending error again. They may be taking the same number of pencils that Willa has to begin with and just simply adding it to it. So, in summary, the question depended heavily on students' decoding and comprehension skills. So, based on the analysis of this question, I would suggest the following. 1. Ensure your students are competent and confident with one-to-one correspondence, and then they can apply this skill in similar word problems. So students practice using both concrete and pictorial representations and then discuss it as a class how they solve the problem. Please note that it is imperative that you spend time as a group discussing the methods to solve each problem and ensuring students can explain how they calculated the answer, not just deliver an answer. 2. I would suggest being able to keep track of the changes of 2 quantities at the same time. It's also a skill that must be practiced, discussed, and practiced again. The various strategies that your students apply should be discussed and shared. 3. Modelling and unpacking of multi-layered word problems by the teacher is paramount, including scaffolding, concrete and pictorial representations, and of course, visible thinking at all times. The teacher should be constantly assessing student understanding through tools such as mini whiteboards and apply a gradual release of responsibility, aiming for student independence. Do less questions with more discussion and reflection with the whole class. I'm hoping that one of the strategies you may have considered is a think board. A think board can aid students in decoding and comprehending word problems. Now, this think board promotes a concrete pictorial abstract approach. So students have to represent the question and their thinking in all 3 forms. Now, this approach develops a deeper understanding in the shift from concrete to pictorial and then finally the abstract approach. Many students are very successful when they are utilising concrete materials, but they struggle when they must apply either the pictorial or abstract formats. So using a tool such as this think board promotes and values all methods of modelling, but This is only successful if a class discussion occurs after attempting each question, where all students can question and clarify their thinking. And then the teacher can also assess student understanding, triage as needed, and decide where the lesson heads to next. Pause if you want to and discuss. Now here is an example of a question targeting years 2 and 3. Carefully read the question and then consider and discuss each focus question. You may find you might want to discuss the focus questions in a different order. That is no problem. Pause the video for approximately 5 minutes to discuss the focus questions. Ensure that someone is scribing, and as I said before, I would recommend a whiteboard with different coloured pens. Discuss and add to the board as you work through each focus question. And when you are finished, recommence the video. Welcome back. Let me present my thoughts on each of the focus questions. So starting with focus question 1. Well, the key concepts and skills necessary to successfully answer this question would include knowing and understanding the language of subtraction. This seemingly simple question was challenging for many of our students. The next would be being aware that mathematical symbols are part of a language used to specify operations. Also, understanding that the same mathematical operation can be represented in our language by many different words and phrases. So my question to you is, what learning and teaching strategies are you currently employing in your classroom? And what could you add to the learning to ensure that your students are competent and confident to identify words that are specific to the 4 operations and are able to connect the correct mathematical symbol to the word? Pause the video and discuss. Focus question 2. What are the prerequisite skills and knowledge? Well, students need to have a deep understanding of whole number and subtraction, as well as mathematical symbols. Now, if you have not heard of Newman's error analysis, then here is a quick summary. The analysis breaks down the 5 steps involved in solving a mathematical word problem. Reading and decoding. This is where the student reads the problem and decodes the words and symbols. Comprehending. The student makes sense of what they have read. Transforming. The student mathematizes the problem, that is, works out what mathematics needs to be done. Processing, demonstrating what to do to get the answer. And finally, encoding, records their final result appropriately. So let's work through each distractor in this question. The plus sign. Well, this is a comprehending error. Students may misunderstand or simply not understand the meaning of the term difference. Subtraction, well, of course, this is the correct answer. Division, another reading decoding error. The student may have confused the words difference and division as they start with the same letter, D. Multiplication, well, this is a reading decoding error as well. Students possibly don't understand what the question is actually asking. So, in summary, the question depended heavily on the student being exposed and understanding the language of subtraction in a word problem. Based on the analysis of this question, I would suggest the following. Avoid teaching mathematic keywords in isolation. So what I mean by keywords are essentially words that we associate with certain problems. Now, I know this is a strategy that has made its way into many classrooms, and it teaches students to look for certain words to determine whether they should add or subtract, multiply or divide. Well, teaching the mathematical keywords for each operation in isolation can be very misleading. If we take these words out of context, then misunderstanding can easily occur. Now, there are 2 main problems when focusing on just the keywords. One, there are many examples where the keyword doesn't actually indicate the expected operation. Now, here's an example. Please read. The keyword more indicates addition, but in fact, the problem requires subtraction. Now, there are word problems that don't have any mathematical keywords. Please read this example. Again, there are no keywords to indicate the intended operation. Here is another example. Again, no keyword. So if we teach our students to be reliant on keywords without context, how can they demonstrate their mathematical knowledge when they are confronted with these kinds of word problems? Encourage your students to stop, read, and think about what the word problems are asking. Possible strategies to get your students thinking about word problems include: make it interactive. Encourage the students to move, act out, draw, write, or talk about the question. Ask your students to retell the word problem in their own words. Ask them to explain what is happening. Allow time to process the problem and make meaning. This is crucial. Focus on what each operation means. What are the big ideas for addition, subtraction, multiplication, division? What do these concepts look like? Again, the power of talking and discussion in mathematics is paramount in forming strong foundations and clarifying misunderstandings and misconceptions. Here is a very clever strategy. Introduce your students to numberless word problems. So what does this mean? Well, remove the numbers. This promotes thinking about the context of the word problem rather than focusing on the numbers. And remember, promote discussion. Discuss as a group. What do you know? What do you wonder? What mathematics do you think you could apply? Is there actually an answer? Encourage your students to draw or write about what they know. So, here is a numberless problem. Pause and discuss the prompts for this statement. Then begin to introduce numbers to the problem. Again, stop and discuss the problem using the prompts. And then again, discuss the problem. This approach is extremely effective in building understanding about the need for context and reducing the reliance on just the key words. You will still need to note keywords, but don't display them out of context. Here is an example of a question targeting Year 4. Carefully read the question and then consider and discuss each focus question. You may find that you want to discuss the focus questions in a different order. That's no problem. Pause the video for approximately 5 minutes to discuss the focus questions. Ensure that someone is scribing and discuss and add to the board as you work through each focus question. And when you are finished, recommence the video. Well, let's consider each of the focus questions for this sample. Well, the key concepts and skills that this question would be targeting is subtraction strategies with 3-digit numbers. The prerequisite skills and knowledge would include subtraction and facts of 10, subtracting 2-digit numbers, and place value of whole numbers. So let's work through each distractor in this question, and I will be referring to Newman's error analysis. And if this is new to you, please rewind the video back to 11 minutes for a quick explanation. I have also added an image with the elements of a subtraction algorithm labelled. Let's start with AJ. Well, this is a comprehending or transforming error. Students who selected AJ may not be able to determine the level of difficulty of a mental 3-digit subtraction, or just how to make it simpler. Bess, of course, has the correct answer. Chris, this is a transforming error, likely to have rounded 497 to 500 and then used an incorrect strategy to compensate for that 3, such as subtracting 3 from the minuend rather than adding 3. Della, another transforming error. The student may have rounded 497 to 500, but not compensated by adding 3 to the minuend. And Eli, again a transforming error. The student has probably misapplied the correct process for simplifying a subtraction calculation. That is, thinks that if they decrease the subrahend by 2, the minuend must be increased by 2. What should occur in the teaching and learning? Well, firstly, subtraction is often the poor relation to addition in scope and sequences. Please ensure that subtraction receives a respectable time block, not just squeezed into the last week as addition took too long. To apply subtraction skills effectively, students must be fluent with subtraction facts. Now, this is not just memorization of basic subtraction facts, but includes being flexible with the basic facts. When there is no need for supportive tools such as number lines, fingers, or manipulatives. Being able to select the appropriate strategy, being efficient, and of course, finally, accuracy. Now, while being fluent with mathematical facts won't make a word problem easy, it will reduce the number of cognitive resources needed to complete the computation part of the process. Now, according to our curriculum documents, students are taught strategies to simplify the calculation of a subtraction algorithm, but unfortunately, the learning experience is often isolated. So students see very little value or need in the application of the strategies. Many students don't believe that adding the same amount to each component of the subtraction algorithm achieves the same answer as the original algorithm. Now, this is because students have not investigated and made sense of the concept, so they don't value it. Investigations into adding or subtracting the same value to each component of the subtraction algorithm and discussing findings as a class will promote reasoning and valuing of the concept. Here is an example of a question targeting years 5 and 6. Carefully read the question and then consider and discuss each focus question. You may find that you may want to discuss the focus questions in a different order. That is no problem. Pause the video for approximately 5 minutes to discuss the focus questions and ensure that someone is scribing. When you're finished, recommence the video. Well, this sample question focuses on the recognition of the relationship between two given division statements. It was done very poorly. The key concepts and skills that this question targets include being able to identify an unknown in an equation and then applying this information in another question, and understanding that multiplication and division are inverse operations and applying this knowledge where the concept of multiplication can be used to solve division problems is probably more efficient and vice versa. So what are the prerequisite skills and knowledge of this question? Well, a deep understanding of the equivalence and its symbolism. That is, students understand that equal sign means is equal to or the same as, rather than the terms make or gives. It is crucial in a question such as this. Be very aware of the definitions your students have for the equal sign. The other prerequisite is inverse operations. So in this question, understanding the link between multiplication and division facts. Well, let's work through each of the distractors using Newman's error analysis. Now, if you need an explanation of this, please rewind to 11 minutes on the video. Well, 1, it's a reading decoding error, or it could also be a comprehending error. Students may have selected the number that comes after the equal symbol in the original equation. 6, of course, is the correct answer. 5, again, is a reading decoding error, or it could also be a comprehending error. Students may have given the value of the unknown, the square, rather than the solution to 30 divided by the unknown. 26, this is a processing error. Students may have used additive thinking. That is, 5 is increased by 25 to reach 30, so then 25 plus 1 equals 26. And 30, it's a comprehending error. Students have imitated the format of the first equation. That is, 5 divided by 5 equals 1, so 30 divided by something, or 30 divided by 30 equals 1. They do not realise that the square symbol represents the same number in both equations. So for our students to transfer their knowledge and understanding into this type of question, we need to, 1, Expose students to solving number sentences where the unknown is represented in a variety of ways and understanding the connection between the equations. For example, in division, where the result is unknown, where the dividend is unknown, and where the divisor is an unknown. The focus is ensuring that students understand the connections of these three equations. 2. Develop a deep understanding of the equal sign and ensure that students are exposed to the correct terminology. That is, the equal sign means is equal to or is the same as, rather than the terms makes or gives. Students must understand that the value of either side of an equal sign is the same. Also, it must be noted here that if the same symbol or letter is used in a connected set of equations, then the symbol would represent the same value. Hence, the three equations shown have different symbols, whereas the sample question uses the same symbol, that is, the square. Ensure that our teaching and learning strategies include investigating and identifying inverse operations, and how the concept of inverse operations can be applied to a variety of mathematical problems. Practice identifying the inverse and applying this knowledge to use multiplication facts to solve a division problem and using the concept of division to solve multiplication problems. So, did we hit the mark? Here is the success criteria for Webinar 2. Discuss them with your team. And thank you for joining me today. Remember, there are 4 more webinars available. Their target audience will be teachers, and they will focus on building capacity on each of the areas of concern drawn from the PAT Maths data. Thanks again for being here.